Hello, everyone. I'm Mike Smith from Rising Tide Cybersecurity Management, and today we're talking about analyzing and manipulating controller area network, or CAN traffic. This is part 2 of a 3-part series. Part 1, we introduce CAN. What is it? What's a CAN bus? And how to build and run Instrument Cluster Simulator, or ICSim, which is a controller and an automobile that communicates across CAN. And we looked at a couple different utilities that are available on the Linux platform or the Linux operating system to send, receive, and view CAN packets or CAN frames. Today, we're talking about more packet capture and especially on manipulation of that packet capture. And then in step 3 or video 3, we'll be talking about CAN packet fuzzing and some of the software that I wrote called CAN hacks that allows you to do that more efficiently. So as I said, today we're talking about CAN packet capture and manipulation and using some of these utilities that we talked about in the last video to record packets or frames, manipulate those, so change those, alter those, and then use those to actually send whatever kind of traffic that you want to send. I want to start with ICSim in the GitHub project page. I'll put the link down in the description of this video, but you can just search for, hey, if you just Google for ICSim GitHub, you'll find it. Right? But it's very, very important when you start looking at CAN frames that there are 2 pieces of that frame that you need to understand. And the first one is the CAN ID, which is usually 3 characters in hexadecimal, and the payload. And the payload is variable length, but it's always paired because it's bytes. But it could be as short as 4, and it could be as long as, I've seen them up to 12, but in the spec itself, well, not in the spec, but when I wrote software to manipulate frames, I carried it out to, I think, 24 characters. Okay, but you don't really know what the CAN IDs are for a particular system. Sometimes they're documented. A lot of times they're not, and you have to figure it out. Now, for ICSim itself, if we go look inside of the code, so we look at ICSim.c, and we scroll down, they'll actually have this defined as constants here. So they've got default door ID, which is in binary, it's 411, and in hex, it's 19 Bravo. And they also have the signal ID, which is for the turn signals, and that's 392 in decimal or 188 in hexadecimal. And the speed ID, which is the vehicle's, the current speed of the vehicle, that's ID 580 in binary, or excuse me, in decimal, and it's 244 in hexadecimal. Now, one of the resources that I use a lot is a hexadecimal to decimal converter. So if I go, say, 580, and I want to convert, swap those out, 580, convert that gives me 244 in hexadecimal. So I'll use this a lot, especially when we start looking at the payloads, to see if I can break the payload out and understand what the payload is actually telling me. And that takes us to Kali Linux. Now, in video 1 of the series, I set up ICSim, I set up a CAN device. So I want to do a quick check here with ifconfig to make sure that I still have that vcan 0 device that's set up. And I'm here inside of my ICSim home directory. So what I want to do is go in and run an ICSim and run my controls. So it's /ICSim vcan 0 and ampersand gives me my shellback. And I'm going to move that over here. And then I'm going to do controls vcan 0 ampersand. That gives me controls. And the controls are labeled here. I talked about this in video 1. The left, right arrows on your keyboard turn the signals. The accelerator is the up arrow. There's no brakes or decelerator. You just let go of the accelerator and it'll gradually go back to 0. And then you use the right shift and the left shift on your keyboard in combination with the A, B, Y, X keys on your keyboard to lock and unlock the doors. Right? And so what I want to do is two things. Number one is I want to show you what happens when I have two controllers that are sending signals to the ICSim. So here I have two controllers. I'm going to bring them both to the front here. I'm going to use this controller, and what I'm going to do is I'm going to push the up arrow, and you watch that speedometer there, right? So I'm accelerating on the one controller that I'm controlling, and you'll see that needle flip-flops back and forth between 0 and, in this case, the top speed. And there's a reason for that, because I have two controllers. The controller that I'm manipulating and telling to go faster is sending one speed sensor, right? And it's just a sensor. And the other controller is sending that the speed is 0. So that instrument cluster simulator is flip-flopping back and forth. Now, the reason that you need to understand this is because once you start manipulating your packets, you're sending extra packets. And keep in mind that the controller, if it's up and running, will send signals that are contrary to what it is that you're sending as manipulated traffic. Right? So I'm going to close out one controller. That takes my speed back down to 0. And now I'm going to do a packet capture, and I'm going to exercise all of the functionality of the controller. So in order to do that, I do candump -C, which is what the CAN device is, vcan0, and -L will log this traffic to a file. And it'll log it to, it's a candump and then a date timestamp. So you'll see it right here. Now what I want to do is exercise all the functionality. So I click on the controller. I'm going to do speed first. I'm going to go up, 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 up. I'm going to take it to the maximum speed here, and then let go and let it come down. Okay, and then I'm going to do left turn signal, then right turn signal, then doors. So I'm going to go right shift, A, B, Y, X. So that unlocks all the doors, and you'll see that on the car. They're all red. And then I'm going to do left shift, A, B, Y, X to lock them all. And now I have exercised all of the functionality of the controller, and I'm going to go ahead and Control C. Now what that does is it made this file right here, candump 2022-02-23. You obviously know what date that I'm recording this and what time that I'm recording it at. And I do ls, and you'll see that it's there. And I have a previous one here that I made on the 22nd. The 23rd is the one that I want. And if we just do a simple candump 2022-23, you'll see that what we get is this format here, where we've got one column that is the Unix epoch time. So this is the total number of seconds and the total number of milliseconds since the Unix epoch, so April 1st, 1970. Then we have the device that we actually captured the traffic on, and we have the actual CAN frame here. The first 3 characters, right? And this is all in hexadecimal, in case you can't eyeball that. It's all hexadecimal, right? So the highest is F, the lowest is 0. And these 3 numbers here are the CAN ID. They use the hash key or the pound sign as the delineator or the separator. And then you have this piece here on the right-hand side, which is the payload. So you see the payloads could be as small. Here was 4 characters for ID 039. And you'll see something a little bit longer here for something like 13A, where it stretches all the way out to the right. Right? So that's cool. Now, there's some other things that we can do to manipulate this. Very, very simple stuff just using the Linux command line. So if I want to find the speedometer, and if you remember, the speedometer is 244 in hexadecimal. So I can do something like grep 244 pound or hash key candump 23.log, and that will give me an extract of all of the speedometer traffic. So now all I have to do is drop that into speedo.log. Okay, now I can cat speedo.log, and that will give me that extract of all the speed that I recorded in my sample. Now, because I'm going to start manipulating this traffic, I want to make my terminal a little bit bigger here, or a lot bigger, as the case may be. So that way you can see a lot of what I'm working on, because I got to get into an editor here. The first thing that I want to do is use a resource called canplayer. And so canplayer -i, and we want to do speedo.log. Okay, and what that will actually do is it will take this extract of all the speed data that I put into speedo.log, and it will run that on the instrument control simulator panel there, and you can actually see that speedometer increase. It'll take a couple seconds. Then you'll see the needle starts to rise. Obviously, I'm going to control C it here. And this was intentional. I had the controller up and running, so you can see that speedometer was jerking back and forth. So I'm going to go ahead and kill out my controller. Now I'm going to apply my speedometer here, and you should see a nice smooth transition up to the maximum and then back down. Okay, and that is the replayer. Now, it's not that eventful to just replay traffic that we've already seen. I much more prefer to manipulate traffic, and so let me take you through what that actually looks like. So the turn signals themselves are 392. Let me check and make sure. So the ID for turn signals is 392, or in hexadecimal, it's 188. So if we actually take do exactly the same thing we did with the speedometer, and now we will grep, what is it? 188 pound candump 23. That should give me all my 188s, and you'll see a lot of zeros there because that's a turn off, or off, 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 off. I'll show you in a second here what this looks like. Let's dump it into the turns.log. Okay, now we can do less turns.log. And what you'll see is that we've got a lot of zeros. 0, 0, 0, 0. If we scroll down, we scroll down, we scroll down, at some point here, what you'll see is we've got 1, we've got 1, we've got 1, we've got 1. And then we've got 2, 2, 2, 2, with a 0 in between. So oddly enough, the controller software here, it doesn't send like you would think, which is it would send a signal to the controller that says left turn signal turn on, and then the turn signal automatically says, oh, turn on, turn off, turn on, turn off. The controller actually micromanages that turn signal. And so what you see here is you see it says, here's a 0, 1, and that turns the turn signal on. And then it sends a 0 to turn it off. And then it sends it a 1 to turn it on, and a 0 to turn off, and a 1 to turn it on. And if you look at this timing here, so here is the first turn the left blinky on, and you'll see here it is 1074, 0.43, whatever. And then you'll see at 175, it, right, and then half a second later it turns off, then half a second later it turns on, then half a second later it turns off. So you can actually view the timing in that date timestamp of how they are changing that turn signal. Okay. So what I want to do, and you know, I can do the replay. Let's take that. So let's replay our turn signals. So just canplayer, send it to the canplayer. It'll take a little while to turn it because I did all of the speedometer stuff first. Eventually we'll get there. Okay. Now this is a problem with using can replay and using the packet capture raw like that, is where we have a bunch of nop, or just all zeros, no action. See there, now the turn signal's turned on, left turn, and then the right turn. So I know that in my packet capture, I've got 1s first. 1 is the left, 2 is the right signal. If you go look at the code for ICSim, you'll actually see that that echoes what's happening. And then I messed with the door, so I'm going to Control C that. So what I want to do is extract the time when I was actually running the turn signal and get rid of all this 0, 0, 0, 0, 0 stuff at the beginning. So I'm just going to go ahead and edit that. I'm going to go down to where I start seeing the 1s, which is right here. That is on line 61. So you see that's down here in the lower right hand corner. That's line 61. So I'm going to go up to the top 1G. I'm just going to shortcut. I'm going to do 55 DD. That deletes 55 lines. Okay, so I get rid of all these extra lines up at top. So you see now I'm at line 1, and then I'm going to go down to the end here, and I'm going to go, 55 DD. That's looking pretty good. That chopped all of the end lines, and so now I just have an extract of just the time when I was running the turn signal. Okay, I go ahead and drop that. And now I can go back and run my canplayer, and you'll see the turn signals immediately start. So basically I just cut the beginning, cut the end, gave me the chunk of frames that I'm actually interested in, and now I can go replay that. Now that I can manipulate the turn signals, I want to show you one last trick for manipulating logs, and that is generating your own logs. So if I actually I've got turns.log, right, which looks like that. Now I can do just a simple head-n1, which gives me the first line of that log. So I want to head-1 turns.log into three-way.log, okay, because I want to see if I can figure out how to get the three-way flasher to work. So I'm just going to grab one line. I'm going to do vi three-ways.log, and so you'll see there's one row there, and it's just zeros. It's just all zeros. So what I want to do is I want to do a yy p. So I'm just going to copy that line and paste it a bunch of times. And then in this case, I know that we're using, I believe it's the second character. I have to actually go back and look. Yeah, it's right here. It's the second character. And so I want to start with a 0. I want to go here. I want to add in something like 3, right? So I use 0, 1, 2. The next one would be 3. I know that it works, but sometimes it's an educated guess. And I want to come here and I want to say this is going to be 4. So I'm going to manipulate my timestamps. 5, 6, 7. So instead of half a second between flashes, I'm making it a full second just because it's easier. I don't have to do this weird funky math while I'm on camera, which is always hard. Okay. Eight, 1, escape. Okay, and now I want to go over here and manipulate some of these guys. X and 3. X and 3. Whoops. I have to leave a space in there. Okay. X1 and 3. X1 and 3. Okay. So what I have here is a file that I made. And you'll see every second, right? So I just increment by 1. Not a big deal here. And then over here I have 0, 3, 0, 3, 0, 3, 0, 3, 0. Totally cool. Exit out of there. And now I'm going to use my canplayer to 3ways.log. And play it, and boom, I have crafted payloads, okay, to make that 3-way flasher work. And then the last one that I want to look at and analyze, which is the doors. And the door ID, or the can ID for doors in hexadecimal is 19 Bravo. And so we can go do exactly the same thing. So grep 19 Bravo pound candump 23 into doors.log by doors.log, and sweet. That didn't capture, there's not a lot of zeros like you get with the turn signals, but what you do notice is here you have Echo, Charlie, 4, 0, 1, 3, Bravo, Foxtrot. And so, yes, that's definitely, we're using that. I believe it's the 5/6. 1, 2, 3, 4, 5, 6. 6 character space. And so you'll see here, we start with something like E, we end with something like F. We do have a 0 that's in here. And so I want to actually grab this. I'm going to just do a file new tab here because I want to be able to steal these. And so what I'll do is I'll go here. I just did a cat of doors.log. Cut and paste in Vi wasn't working for me. And so I'll just highlight this, go here. I've got cansend vcan0, and then I middle click and that drops that in. So I can go ahead and send all of that payload, and you'll see nothing happen. So with an F there, that probably means doors closed. I can go back up here and try 19 Bravo with all zeros, right? So normally you test the top, you test the bottom, and then you do a little bit of stuff that's in between. Oop, I have to actually send a vcan here. Can send like that, blotto that part, drop in that, hit return, and you'll notice over here on my controller, everything's red, so I unlocked all the doors. Now I can go through and step through this by changing this, so I can do 1, right? So I send 1, it unlocks everything except for the left front. 2, and you can just step through all these, right? So 2 happens to be the right front. 3, strange things might happen. So 3 is the front and the right, or both of the front doors. 4, okay, which is the left rear. 5, which is the left side, and so on and so forth, right? I want to actually lock everything up, so let's send a F. Okay, so F, we've locked everything up. It took me a while to figure out what exactly was going on with the doors. Eventually what I had to do was go back into the ICSim code and look at a little bit of what's going on here. So you have, because I was thinking that just like with the turn signals, you would send a can message that says lock door 1, a can message that says lock door 2. And that's not actually what happens. What happens is that in the code, they define door lock is door 1 is 1, door 2 is 2, door 3 is 4, door 4 is 8. And they just add these numbers together. So instead of sending lock and unlock each individual door, what they send is the current state is this value. And this value is determined by adding which doors are locked, adding their value together. That's why F, which is 1 plus 2 plus 4 plus 8, in hexadecimal is F, or foxtrot. And so that is basically adding all these together and saying, yes, the door is locked. Right? By that extension, you would say E is this plus this plus this, because it's 1 down from F. And so you remove 1 from F, and that gives you E. Okay, so the same thing. You could say here is 4 plus 8. So if I want to lock door 3 and door 4, 4 plus 8 is 12. You convert that into hex, and just doing this on the fly, that gives you Bravo. So if I send a Bravo, then doors 3 and 4 will be locked, and doors 1 and 2 will be unlocked. So let's go test out my hypothesis here. We're just going to use the up arrow, come back, change my F to a Bravo, and send it. And I get 1 door, so apparently I was off by 1. But you get the idea. Apparently doing hexadecimal math in my head while I'm recording is a difficult thing to do. And with that, this ends our segment for video 2 on CAN packet capture and manipulation. Please join me next video when we start talking about CAN packet fuzzing and a little bit more in-depth analysis. And I will see you there.